Hello, geometry. Here we are. We're going to do Unit 1, Lesson 9. Uh, the In the beginning there, we did a little what do you notice, what do you wonder, and we talked about uh, points in a space and the space being divided up, and some uh, guesses that we could make about that space. So now what we're going to do, we have a city here, is this square, and we have three locations of the same store. So, for example, these are the three Dunkin' Donuts in New England that are all within 2 blocks of each other. That's just a little joke. But uh, number one, the company wants to break the city down into regions so that whenever someone orders from an address, their order is sent to the store closest to their home. They've hired you to decide how to partition the city between the three stores, and we're going to explain or show our reasoning. So we want to split this square up into three separate areas so that everything that is, everybody that's closest to store E will get their items from store E. And to do this, what I want to do is I want to go back to Unit 3, I'm sorry, Lesson 3, Unit 1, Lesson 3, and I want to remind everybody that we made a conjecture, and our conjecture was that the perpendicular bisector of a segment consists of all of the points, the set of points that are all the same distance away from A as they are from B. And here we had the perpendicular bisector, point A on the left here, and point B on the right. And we said, well, if we make this perpendicular bisector, every single point on this line is going to be the same distance away from A as it is from B. And it seemed to make sense. So what we're going to do here is realize that if we can create the perpendicular bisector of each of these points, we can divide this up. So what I'm going to do is I am going to connect these points using the segment tool. And notice what I've created here is a triangle. Not surprising. Now what we want to do is we want to create the perpendicular bisector between E and G. And remember, to do that, what we did is we drew a circle from E to G, drew another circle from G to E, and then found the intersection of these two circles and said, well, if we draw this line, HI, that will be the perpendicular bisector, and it makes sense that everything above this line is closest to E and everything below this line is closest to F. So this is how the old way that we created a perpendicular bisector. What I want to show you, though, is that there's actually an easier way to create a perpendicular bisector. If you come up here to this other tool, we can make a perpendicular line through a point, a parallel line through a point, perpendicular bisector, angle bisector. Tangents, lines of best fit, all this, we'll get to that later. But we want to create a perpendicular bisector of this line segment. Click on it, and there it is. If we want a perpendicular bisector of EF, we can just click on it, and there it is. Perpendicular bisector of GF, we click on it, and there it is. Something I want you to notice is notice here in the middle, at point H, all of these perpendicular bisectors intersect, and this is called a point of concurrency. So this is the point where all three perpendicular bisectors for a triangle intersect. Okay, so this point H is the same distance away from E, F, and G. Okay, that point H is the same distance away from all three. So what we've done is we've just divided it up. Okay, with these segments here between E, F, and G, it can make it a little bit difficult. So I want to show you that you don't even really need those segments. So if I want to find the perpendicular bisector between E and F, I choose perpendicular bisector, I click E, and then I just come down and I click my next point F. There's the perpendicular bisector between E and F. Now I can do the same thing for all three, and notice it just makes a little bit cleaner. Makes it a little bit cleaner. So what I want to do is I want to now shade in these regions. Okay, and in order to do that, I'm going to use the polygon tool. Well, first I'm going to find all the important points. So I know that this point in the middle here, H, that's important, right? This point of concurrency. I also notice that the points where these bisectors intersect my square, or the town borders, these are also important. Okay, so those points are all important as well. So now what I'm going to do is I'm going to use the polygon tool, and I'm going to shade in the area in E, that the area where E should be covered. Okay, where store E should cover. So I'm going to start far away from the other 2 points, and I'm just going to start drawing a polygon. And as I go, what I need to do is I need to think, okay, now I'm at this point. Should I go up here to N, or should I go over here to M? So everything on the left-hand side of this line is closest to E, but that is not as it relates to F. So I want to choose the line that is the perpendicular bisector from E to F, and that line goes up to M. Then come over and end it, and there's my polygon. Okay, now I'm going to do the same thing for the others. I'm going to go from I to H. I want the perpendicular bisector between G and F, and that is this one that goes down to K. Comes over, up to I, done. Now what I want to do is I want to change this area. So I'm going to go over here to this little tool. Remember the tool where we can change the colors. And we're going to change it to whatever that color is. Red, I guess. Okay. Now we're going to do one final polygon. And we're going to go from here to here. And then over to K. Up to H. Up to M, and finish. Change this color again, and let's make it, I don't know, this red color. Okay. So there we go. We got, oh, made another polygon. We divided these areas up. Okay. So we just partitioned the city between the 3 stores. For the explanation, well, I know that this divides it up evenly because I use the perpendicular bisectors, and everything that's closer to the point of interest on the side of the perpendicular bisector is going to be closest to that store. Now the question is, if there are 100 employees, how can they be distributed among the 3 locations? So to answer that question, what we need to think of is we need to decide, so looking at these, the 3 areas are not equal, right? So what I want to do is I want to figure out how big each of these areas are. And this applet will actually do that for me. If I come over here to where my measurements are, right, where I could take an angle measure or distance or length, I want to find the area and just click the part where I want to find the area. Just click the area and it calculates it for you. So here we have these 3 areas. Okay, those are our 3 areas. And I think at this point we're pretty much done with the applet. So let me take a screenshot of this, and I can snip it into OneNote. So copy back here to OneNote. Paste it in there. All right. So there we go. Now we can answer the questions. If there are 100 employees, how should they be distributed among the 3 locations? Well, the first thing we have to do is we need to figure out uh, what is the total area of this square. So to do that, there's one of 2 ways. We could go back here and we could figure out the length of each side, right? So if we choose length from A to D, that's 7. And from A to B, that's 7. So the length of each side is 7. The area of this square then is 7 times 7, or 49. Or, so we know that we had 7 times 7, so the area is equal to 7 squared, or 49 is the total area. Or we could have just added each of these up. So 14.4 plus 15.2 plus 19.4, 19.4. Sum those, and we see we get the same thing, 49. So what we want to do now is figure out what percentage of the area is each store responsible for. So we will do the E first. And to find the E percentage, so we're going to find the percentage for E. We're going to take the area of E, which is 14.4, and divide it by the total area. Okay, so 14.4 divided by 49, and we get 29%. Find the F percentage. We're going to do the same thing. We're going to take the 15.2 and divide it by 49. And that is 31%. And then for G, we're going to take the 19.4 divided by the 49, and we get roughly 40%. 19.4 divided by 49 is 40%. Now, make sure that these all add, make sure that these sum to 100%, okay? Because the rounding might mean that we have to bump one up, or some, we might have missed a percentage point. So 29 plus 31 plus 40 does sum to 100%. So these are good percentages. So if we have 100 employees, how many should be among the 3 locations? Well, at location E, we should have 29% of the 100, or 29 total employees should work at store E. At store F, we should have 31 employees. And at store G, we should have the most, 40 employees. Okay, and again, is there anywhere in this city that has the same distance to all 3 stores? Yes. Point H is equidistant from all 3. So if there is somebody that lives at point H, it doesn't matter where they get their merchandise from. Okay, so that's the first problem. The second problem that we were asked to do is the same thing as the first. Okay, And what we're going to do is we're going to find these perpendicular bisectors,